Hello everyone, welcome back. Today's video is on plate tectonics. Today we're going to cover how the movement of three different types of plate boundaries can cause earthquakes, volcanoes, and build mountains. Then we're going to break them down into convergent boundaries, divergent boundaries, transform boundaries, and all of the landforms and structures we can find with both. So I first want to introduce the concept of convection. There are three different types of heat transfer in physics, one of them being convection and the other two being conduction and radiation. Radiation is the movement of energy through like space. Conduction is the movement of energy or heat through a material, through a solid material. And convection is the movement of a fluid and the movement of energy through a fluid. And it's this tendency of liquid to rise when it's hotter and then cool down when it's away from your heating source and then sink back to be heated up again. And it creates these convection gyres that move liquid around. If you've made a pot of rice before, you might have seen the grains of rice when it starts simmering. The grains of rice are spinning around. You're not spinning it at all, but it's being churned and turned over because of convection. And that's because warmer things are less dense, they're lighter than colder things. Cool molecules, cool materials are more dense, and dense things sink to the bottom, where light things like to rise to the top of whatever they're in. And so that exact same thing happens within our Earth. There are four chemical layers of the Earth. You have the inner core, the outer core, or just the core, and then the mantle and crust. And then these are also defined as physical layers, the lithosphere, the asthenosphere, the outer core, and the inner core. They all have different material properties, but what we really are looking into with plate tectonics and all the things that come as a result is the liquid nature of the asthenosphere and the solid nature of the lithosphere. So our crust, the ground, is a solid material, but it's laying on top of this convecting liquid material, liquid magma that's just churning really hot and deep pressures. So it behaves like a liquid and does this heating when it's closer to the core, and then it gets farther away from the core. It heats up, it becomes less dense. Once it reaches the Earth's crust, it starts to cool, then it becomes more dense, and then it reaches the core again and continues that convection process. And so with that, you get a slab pulling motion as it's reaching the crust and moving across and cooling down. It pulls that piece of lithosphere that it's seated right below with it, which in turn just moves the whole lithosphere crust downward, away from a divergent boundary and towards a convergent boundary that then subducts back into the crust or into the mantle, remelts, and the whole process just continues again. And that is the principle of plate tectonic theory. The Earth's lithosphere is separated into these plates that move over the asthenosphere because of convection of the Earth's mantle. Here we have the California West Coast is on a transform boundary. If you move to Northern California, Oregon, or Washington, it's on a subducting boundary. And all of these arrows tell you which direction they're moving away from. And they're moving away from each other, they're diverging, they're moving towards each other, they're converging. And here's a breakout of that. We have the North American plate, which composes parts of Russia and all of North America. South America is on its own plate, Africa. Over here, we have the Arabian plate. There's even some smaller plates on this Eurasian plate. India, Australia, pretty much every continent sits on its own plate. And we live in a very seismically active area in California, and that's due to our proximity to this transform boundary. I've touched on a few of these already, but there are three types of tectonic boundaries. We have convergent boundaries, divergent boundaries, and transform boundaries. Convergent boundaries are moving towards each other. These can subduct or cause collisions. We have convergent boundaries, which are found in ridges or rifting valleys. And then we have transform boundaries, which are moving past each other in a left-right motion. Passive boundaries are also possible where plates aren't moving at all relative to each other. And a great example of this is the North American East Coast also sits on a plate boundary, like you can see. Well, I guess you can't see it in that video picture, but there is a boundary over there, but it is not active. There's no motion happening relative to each boundary. So more on convergent boundaries. These are two or more plates. It can be more than two plates moving towards each other, pressing towards each other. There are two types of convergent boundaries. We have subduction. So then we're looking into density again. The denser plate is going to sit lower and be pushed beneath the lighter plate. The lighter plate is going to want to stay on top. So the continental crust and the oceanic crust have different densities, and the continental crust is always lighter. And so when the oceanic lithosphere meets the continental lithosphere, the oceanic plate usually subducts, and that's due to this difference in density. The oceanic plate is denser, and so it subducts. If they're both oceanic or they're both continental, the warmer younger plate, how old a plate is will tell you, will give you a density, a heat associated with it. Remember, hot things are lighter, and so a warmer, newer plate is going to stay on top of an older, colder plate. And so that's when there isn't a difference in the types of plates meeting. A collision occurs when an equal density of plates converge without subducting past one another. And this is common in continental plate collisions, like the one that makes the Himalayan mountain range, the India plate and the Asiatic plate meeting each other. So more on subduction. Subducting plates can cause trenches like the Marianas Trench. They actually scrape off bits of the plate they're subducting other. So the subducting plate will scrape itself against the non-subducting plate, and it will build up a mass of material called an accretionary wedge, which is basically just matter that's been scraped off of the subducting plate. Much of the state of California is composed of an accretionary wedge. So if you are ever in the Santa Cruz Mountains, you can find things like, I'm blanking on the name of it. You can find suggestions of that once being a marine environment. You can find shale and mudstone that are commonly formed at the bottom of, or slate, shale and mudstone, which are commonly formed at the bottom of the ocean. And now you can find them at the top of a mountain. So those have been scraped off in an accretionary wedge. Subducting plates also cause volcanism, and that's because material that's on the Earth's surface tends to be hydrated or an oxide of some kind. Remember, we live in an oxidative, hydrated environment, and that creates chemicals and mineral complexes that have water bonded to it. The mineral will be wet, like gypsum is hydrated. It has a bond with a water molecule within it. We wouldn't see it as wet because it's still a dry rock, but chemically and crystalline in its structure is water. And so that's what it means when it says hydrated. These materials melt really easily and lower the melting point of material around it. This hot liquid magma is more buoyant than the solid material around it. And so this magma migrates to the surface in these drips that melt off of the subducting plate. So the subducting plate is pushing rock deeper, closer to the Earth's core, increasing temperature and pressure, melting it due to the hydrated nature of the material. That produces magma underground, which then rises to the surface in a volcano. And so you can see kind of an example of that here. You have some volcanic activity from your subducting plate. Just these hydrated minerals lower the melting point of the rock and turn it into magma more quickly than the material around it. The angle at which things subduct can cause deformation from miles away from the subduction zone. The laramide orogeny is the formation of the Rocky Mountains. And so that's caused from the subduction of the San Juan de Fuca plate, or the Juan de Fuca plate. And that's very far away from, the Rocky Mountains are in central United States, western United States. And that is caused from the subduction of a plate on the west coast of the United States. So the angle of which that happens can cause deformation in various locations. Our next convergent boundary type is collisions. That's when two lithosphere plates just slam together and none of them subduct from each other. There's no magma formed in this case, and so there's no volcanism, but you get mountains that have no volcanic activity associated with them. And then an odd, uncommon one is abduction zones, is when a continental plate gets trapped beneath a descending oceanic plate, a section of it, and then it gets pushed down under the overbearing plate and then rises to the top very quickly, which can bring bits of the mantle and ocean floor to the surface in things called ophiolites. Here's an example of a collision, a convergent boundary. We have the Indian plate and the Eurasian plate colliding and making the Himalayan mountains as a result. This may look like it's subducting, but if it was subducting, we would see a large arm of the plate going into the Earth's mantle. So that was our convergent boundaries. We have subducting plates and colliding, or we have subduction zones and collision zones. And now we're moving on to divergent boundaries, which is when plates are moving away from each other. These can be categorized as mid-ocean ridges or continental rift zones. So divergent boundaries can occur underwater or on the Earth's surface. And so in that places on where it's occurring on the Earth's surface, it's going to form these fault zones called rift valleys, where you have keys of Earth sinking down to make up the space that's being sort of stretched out. You don't need to know the definitions of a horst or graben, but just know that these blocks are dropping down into the crust to sort of make up more space as things are being pulled apart as the boundary is diverging from itself. And so this creates a rift valley if it occurs on the Earth's surface, or a mid-ocean ridge if it happens underwater. And a mid-ocean ridge is where most of the Earth material is created. Almost all volcanic activity is associated with a mid-ocean ridge. And it produces a really flat, low-lying zone called the abyssal plain, and that is where matter is created. Here's more on that. You can see the age of the lithosphere in the ocean. In some regions in the Pacific, we have material that's not even 10 million years old. So pretty interesting to see all the new Earth being created in our oceans. Then finally, we have our transform boundaries. So we've covered convergent boundaries, divergent boundaries, and now transform boundaries are when plates are sliding past each other. This is called a strike slip boundary as well. There can be split into two different types. You have dextral faults and sinistral faults. So if you stand on one side of the plate and you look across at the other plate and it's moving to the right of where you're standing of your perspective, it's called a dextral fault. If you're looking at it and it's moving to the left, to your left, it's called a sinistral fault. So an interesting thing about that is there's an association in Latin between left and sinister that has to do with religious motifs and being on the left hand of the Father and all that, like the devil is seated on the left hand of God. So in Latin, sinister and left are synonymous with each other. And so that's where this term comes from. So if it's left, it's sinister, it's bad. Dextral means right in Latin. So if you're ambidextrous, it means you're good with both your hands. You can write with both your hands. You can throw a baseball with both your hands, but it actually means directly that you have two right hands. And so that's what dextral means. And a dextral fault is a right moving transform boundary. A sinistral fault is a left moving transfer boundary. This produces a ton of seismic activity, such as the San Andreas fault. And again, here's an example of that. These two, the Pacific plate and the North American plate, just sliding past each other. And so that concludes our video. Don't hesitate to reach out to me if you have any questions, and I look forward to seeing you next week.